Hi guys. Today I wanted to have a conversation about line plots. Okay. So we've been focused on data, which we know means information, and information is all around us. Right now, we are looking at some data about how many hours of TV fourth graders watch each day. We surveyed our homeroom classes, and this is our represented data from one of our classes. So I just want to review a few of our key terms that we should be thinking about whenever we're analyzing our data. And that means making sense of it so that we can talk more about it. Okay. I see down here, we've labeled 1/2 hour as our minimum. We have 3 or more hours labeled as our maximum. So our minimum is going to be our smallest value that we have data points for, and I see an X over 1/2 hour. So we know that we had a student who watches about 1/2 hour of TV every day, and that's our smallest value that's represented. So that's our minimum. Okay. And I'm looking for the biggest number with at least one X over it. So not there. This one, this one, this one. Oh, this one is our largest number, and it does have data points there. So our maximum is 3 or more. Other key terms that are going to be important for us. If we're thinking about how much space there is between our minimum and our maximum, that's going to be our range of data. Okay, the difference between our maximum and our minimum. So our maximum was 3 and our minimum was 1/2. So if we're counting the spaces between there or finding the distance or the difference, whenever you hear distance or difference, you should think subtraction, right? So 3 minus 1/2 is 2.5. We can see this on our number line because we're counting by halves. We got 1/2, 1 whole, 1.5, 2 wholes, 2.5. So that's our range. We also have an outlier. We've got some outliers out here that lie outside where all of the data is concentrated here. So these two are our outliers, and an outlier is a data point that lies outside the majority of the data. Our last key term is mode. And mode is going to be the value that occurs most frequently. So we've got a lot of X's stacked here. That means that we had a lot of fourth graders who reported that they watched 3 or more hours of TV. So our mode, the value that occurs the most, is 3 or more. Let's do some more practice reading a line plot. Here we go. Here's a line plot. Let's read to find out what this line plot is about. It says Tom was selling boxes of chocolate candy for his school fundraiser. He plotted the number of boxes he sold in the line plot below. Use his line plot to answer the questions. So I have some questions that we are going to talk about for this line plot. Let me get you these questions. So the first question is, how many boxes did Tom sell on day 8? So we're looking at our line plot. Down here, we have the axis labeled for days, and day 8 is right here. We do have a key. It tells us that each X equals 1 box. So I'm just going to count the X's. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the answer is Tom sold 10 boxes on day 8. Here's our next question. Did he sell more boxes on day 7 or day 2? So we're going to look at day 7 right here, and we're going to look at day 2 right here. We should see, because we visually represented our data with this line plot, that there were more boxes sold on day 7 than there were on day 2, because this stack goes up way higher. So we would say that he sold more boxes on day 7 than on day 2. Now I want you to try and answer a question. Did he sell fewer boxes on day 9 or day 6? So I want you to look at day 9 and day 6 and answer that question. Did he sell fewer boxes on day 9 or day 6? Fewer means less. So we're looking at this stack here and this stack here. I see that on day 9, there were less boxes of chocolate sold. So our answer is day 9. Let's think about this. He sold the greatest number of boxes on which day? I see these stacks up here, and I see that he sold the greatest number of boxes on day 6.